Hello everyone, it's Dom here. I hope you're all well and keeping safe. Now what I'm going to do, I'm going to discuss the booklet that I sent you, and of course I sent you some information as well, because we need to be prepared for actually receiving the assignment. So I'll make a start, and I thought what I'd do is do 4 small videos. First one being the proplus tablet, and then moving on to aspirin, then we've got the calcium carbonate extraction, and finally synthesis of the copper oxalate. Okay, so we'll make a start on the proplus first. So you've all got this booklet, and again, if we're going in, it's just making sure that we've got information and we know how to deal with that information as well. Okay, so what I'm going to do is I've got the information here that I sent to you, okay, where I've given you some bits. So the mass of the tablet at the start was 0.2474 grams. The empty vial is 21.923 grams. Vial plus the caffeine, 21.9462 grams. And of course the mass extracted will be 21.9462 minus 21.9230, which equals 0.0232 grams. Okay, so that's how much caffeine was extracted from the proplus tablet. If we look at the next page, so I'll put that to one side, it's asking about the general expression to calculate yield. Okay, so when we're looking at yield, yield is always the amount extracted divided by the amount we should have. Okay, and I'll just say for this it would be the expected amount. Now what I didn't give you was in the proplus tablet there should be per tablet, I'll just write it here, there should be 0.05 of a gram of caffeine. That's what we should be seeing, and of course we got less than that, and I showed earlier that we had extracted 0.0232. okay, oh, and that's times by 100 by the way. Okay, so we'd say 0.0232 divided by 0.05 equal times by 100, I should say, ignore that bit, and that is going to equal a 46.4% yield. Okay, and in fact, as you've probably noticed, that should go there. Good old Dom. Now what we need to look at is, again, key principles and difficulties associated then with the synthetic method. Now, obviously you haven't done this experiment, but I'm going to go through with you, and we're going to pick out 3 different parts of the method and talk a little bit about any problems that we could have. So first one that I want to talk about is number 2 in the experiment, and this is where it's on about grinding up the proplus tablet using a pestle and mortar. Now you've all used the pestle and mortars that we have in the lab at Exton Lane, and they're a fair size, and if you think a proplus tablet is quite small, now if we're going to be grinding up the tablet, you know, the reason that we're having to grind it up firstly is obviously to create a larger surface area so that it's easier, then we can maximize the amount of extraction we can do from those particles formed. So that's the first bit, so that's one. which is talking about principles and difficulties. So what difficulties could we say that we had with that? Well, because it's only one tablet, it is of a certain size, and I think the tablet only weighs 0.25 of a gram, so it's not a great deal. If we grind that up in a pestle and mortar, we're generating a fine powder which will be spread around the actual mortar. And that would mean when it comes to the next stage, when we're transferring the powder then into a 100 centimetre cube beaker, are we going to transfer all of that powder across? And the answer to that's no, because a lot of it grinds into the surface and it reduces the amount that we can then transfer. And of course, when we did the calculation about how much caffeine we extracted, that was because we were thinking that we would have transferred 100% of that tablet from the pestle and mortar into the beaker. And of course, that didn't happen. So that's dealing with that. So that's why are we doing it? Any problems associated with that? Flip side then, how can we improve that? Well, if we think about how much residue's left from one tablet, if we're wanting to maximize the amount we can transfer from the pestle and mortar into a beaker, maybe what we could do instead of using one tablet is maybe using 10 tablets. 10 tablets, we can grind them down, we can then transfer the solid across, and potentially the amount that's left will be a smaller percentage because we're starting with a larger mass. So that's something for you to think about. So that's number 2. Next one we can look at is thinking about, we could mention number 3, we're adding 2 molar sodium hydroxide. And part of the reason that we're doing this is that the tablets have a binder inside them which holds all of those powders together. And if you think, if they didn't have that, that powder will crumble. So the sodium hydroxide there is to help break down that binder, again trying to increase the amount we can extract. But a downside is that it says there will be a small amount of insoluble residue left of this tablet binder. So how could we potentially, if we're not getting rid of all that binder, then potentially that binder, it's insoluble, it's going to be leaving components there. And again, we're thinking when we do an extraction that we're going to be removing everything there, and of course this isn't happening. So again, there's an issue there that potentially we're not breaking down all of that binder. Some caffeine could be left over. Again, a way around that is that potentially we could not necessarily add more sodium hydroxide. We could maybe warm the solution to 40 degrees, something like that. We don't want to boil it because sodium hydroxide is a pretty reactive chemical. It could have an effect on the caffeine itself. So we would just want to warm it to try and make it break down that binder just a little bit more than it would do at room temperature. Okay, so that's another one to think about. Then we'll move down. So another one I'm going to look at is number 9. Now with number 9, we've been going through this process of extracting the organics by using dichloromethane. But in number 9, we have to dry the organic layer because within here we are going to be using water. There will be residual water left over from here. And we use anhydrous sodium sulfate to the organic layer, so this dichloromethane layer, and it's supposed to mop up any water that's left. Okay, so that's why we're doing that. Step 9, get rid of any water because potentially that is a contaminant. But do we know that we've removed all that water? can we say 100% that we have? And we can't. And that's a problem because, again, if we haven't added enough, because in this it just says add a few spatulas, it doesn't quantify how much we have to add. So we could have not added enough, in which case when we move into the next stage where we're going to dry it, where we're going to dry as in remove the organic layer, so we're going to boil off the dichloromethane, there could still be residual moisture left over, and in which case we will get a higher mass than we should, because obviously the water, because we're going to be using hot water, the dichloromethane boils off at 40. Any water that's left over from our organic layer is going to remain there, and that will add to the mass that we've got at the end. So again, that's going to affect our result. Okay, so just a few little pointers to think about there. So I'm just going to turn over. We've talked a bit about that. Talked a bit about improvements to the extraction of caffeine. How could we possibly improve this one? So again, it could be that we're looking at the anhydrous sodium sulfate, and it potentially we could be adding excess of it. So where it's saying adding a few, it might be that we quantify that as saying 5 spatulas, and it might be that what we would do then, instead of decanting the liquid off, it might be that we have to filter it and wash it with some more dichloromethane. We could maybe introduce another section where we add some more sodium sulfate after that. Okay, we don't actually do that, but it's just a thought. Okay, so that's what we can do. So you need to be filling in these sections. Okay, so that's your Unit 22 booklet. Obviously, I've just filled that section in. You've also got this section here. Obviously, make sure your calculation is going to be in there. Just move these across. Okay, so I've talked about 3 different parts of the method. You can use these. So you're talking about why we're doing it, difficulties associated that, and then finally the improvements, again, that I've just discussed. Okay, so something to think about. Okay, thanks for listening, and you'll soon hear me again about aspirin synthesis.